Hi, so in this video we're going to be going over the AQA GCSE Additional Physics module of forces and braking. So to start with, I'm going to refresh your knowledge of resultant forces. And essentially, resultant forces is the force that comes out when you add all of the different forces acting on an object together. So remember that when an object is moving at a steady state, so this could be when it's standing still, or when it's accelerating, so getting faster, or decelerating, so getting slower. All of its forces together, so its resultant forces, are balanced out and equal zero. So when we have a car or another moving object at a steady state, gravity and reaction forces from the ground are involved, and they are balanced at zero. So reaction force is the force that results from when you have a mass pushing down on the ground. A resultant force, or reaction, is what the ground exerts back on the car so it doesn't fall through the earth. And these together are balanced. So blue, which equals gravity, equals red, which equals reaction force. And these are balanced whether the car is standing still or whether it's moving. But there are also other forces involved. So the driving force of the engine, so the engine exerts a force which thrusts the car forward, and this is called the driving force. And the resistive forces, so the forces which resist the driving force, which we'll go into in a moment, are also balanced and also equal zero when the car is moving at a steady state. So when a car is moving at, for example, 70 miles per hour and isn't getting faster or slower. So the driving force from the engine equals the resisting forces. And so there are two resistive forces, the most important of which is air resistance. That exerts the biggest resistive force. So air resistance. And also friction from the wheels. So when a car is at a steady state, the driving force equals the resistive force. So all the forces are balanced, and that is why the resultant forces equal zero. So next we're going to talk about what happens when a car is speeding up. The car is no longer moving at a steady state, and so therefore the sum of its resultant forces, or its resultant force, no longer equals zero. So it does not equal zero. So now we're going to talk about what's happening with each of the forces that are acting on the car when the car is accelerating. Gravity and the reactant force still equal zero. They still balance each other out, because when a car is speeding up, it's not going to be floating in the air or falling through the floor. These forces are always balanced when the car is driving on a solid surface. So we can say that gravity and reactive forces equal zero. So reactant So these aren't the forces that are contributing towards the acceleration. Unsurprisingly, it is the driving force of the engine which increases above and beyond the resistive forces of friction and air resistance, which allows the car to accelerate. So we have a huge driving force, but still the same amount of air resistance and gravity. So essentially that is what's happening with the forces of an accelerating car. Finally, we're going to quickly talk about what happens when a car is slowing down. So again, the resultant forces no longer equal zero because the car is changing speed. Its speed isn't at a steady state. Gravity and the reaction force from the ground are still balanced, but instead of the driving force being bigger, this time the driving force is reduced because you take your hand or your foot off the pedal, your hand if it was a motorbike, and the resistive forces still stay the same, so the amount of friction and air resistance still stay the same, and so are much bigger. So we have a much smaller driving force, which is getting even smaller because you no longer have your foot on the pedal, and air resistance and friction stay the same. And if you want to suddenly stop, you can also add another resistant force called braking force, which is when you apply your brakes. And this is even bigger, braking force, which stops the car suddenly. So these are the different forces acting on a car in motion. I hope this video helped. Thank you.